So, modeling sinusoidal functions. I got to be honest, Logan, in terms of physics, these are some of the trickiest, but some of the coolest applications. There are anything that goes back and forth, that oscillates, that repeats itself, you can model with a trig function, with a sinusoidal function. When we say sinusoidal, we mean sine or cosine, but we're always going to fall back on sine. Okay? Here's an example. A nail is caught in the tread of a rotating tire at point N in the following sketch. As the tire rotates, the nail traces out this path. Hey, what's that look like? This is a trig function. Let's fill in some of the data. It says the points A and C are the maximum minimum points. N, B, and D lie on the midline. We're going to try and actually fill in some of these coordinates and then use that to enter it as in our stat feature and then use sinusoidal regression to get the equation. Use the software. So it says this. The tire has a diameter of 50. So, ready? If the tire has a diameter of 50, how far from here to here? 50. Let's put a little 50 right there. Oh, what would N be? How high? 25. So I can already tell you that this point here is something, comma 50, right? And point B is something, comma 25. Point C is something, comma, help me out, 0. Point D is something, comma, 25. Okay. The tire rotates at 10 revolutions per minute. We'll come back to that. Can you read to me, Jordan, the third bullet after? Oh, you know what I think they've just told me? This x value here is 1.5. In fact, this mystery point is 1.5, comma 50. Is that okay, Brianna? Which means I think, Jordan, oh, can you read to me the fourth bullet point, Brendan? Are we talking about point N, A, B, C, or D? Can you figure out what the x-coordinate at B has to be? No pun intended, but I'll use it. Oh, you know what? Each hash mark looks like it's 1.5. How long to go around once? Oh, why did I say 1.5? Because I'm thinking each hash mark is 1.5. Thank you, Darian. Candy for you. How long to go completely around once? How many seconds? 6. Oh, are you saying that point D is 6, comma 25? This tire rotates every 6 seconds or 10 times per minute because there's 60 seconds in a minute. Okay? Why, then part 1 says, why did he mark a 4.5 at point C? Are you okay with why we said that? We looked at the information that they gave us, and they're either going to give you the information in English like this, or they'll give it to you as a chart, which is easier. You just go straight to typing the chart in, hit your regression button, and do all that stuff. But in English, we can do a rough sketch and get a feel for it. Okay? What's the amplitude of this? It's not 50. I got to be fussy. Because remember we said here is my midline. I'm a little bit too high. Sorry, let me try that a little better. Here is the midline. The amplitude isn't 50. How high and how low are we going from the center? What's the amplitude? 25. What do you tell me the period was? How long to go around? You okay with that, Darian? Right? By the way, when you're talking about a circle, the amplitude will always be the radius because the diameter is 50 from the middle up and from the middle down. Hey, isn't that the definition of a radius? Okay. Hey, how long to go around once? What did we say? You guys answered this already. What's the period? 6 seconds. 6. What's the midline? Okay. We're going to use our software in a second, but I can actually figure out the equation based on what I know. Now, instead of y, what letter do they want me to use instead of the letter y? H of t, they're using function h for height. So the height equals what goes where the a is, the amplitude. What was the amplitude? 25. Sine. What goes where the b is? Not 6. You know what goes there? 2 pi over 6. 2 pi over the period. They don't want me to use an x. What do they want me to use instead? Plus, what's the midline? What's the vertical displacement? Also 25. The only thing I don't like about this question is that both the amplitude and the midline are 25, but that's going to happen when you're dealing with a circle, because if you're rolling something on the ground, the midline is going to be the center of the circle, which is also going to be the radius, which is also going to be your amplitude. Sorry, it's physics. We could also have found the amplitude by going as follows. Menu, stat. Can you all go menu stat, please? And we could enter these points as data. What are the coordinates of point N? 0, comma, 25. What are the coordinates of point A? 1.5, comma, 50. What are the coordinates of point B? 3, comma, 25. Point C, 4.5, comma, 0. And the last point, 6, comma, 25. It's a little awkward. You got to hit enter and then arrow sideways and up, right? But okay, it's doable. Hopefully, if I hit graph 1, does that look sinusoidal? Does it look like a trig function? Okay. Yep.
I'm a bit confused as to how B was 2 pi over 6.
So we said this. B is defined as 2 pi over the period. That's the number that goes in front. And the period is 2 pi over the number that was in front. That's just how, that's what we said you have to kind of memorize. Okay? So it's not a nice one-to-one. It's not like if there's a 3 there, the period's 3. It's actually, the original period was 2 pi. B is going to be 2 pi over the period. That's how you're going to get the original period back.
Okay.
Okay? You all right?
Yeah.
Folks, and again, those of you with the older calculators, you're going to do something a little bit different, but all of us that have the newer ones, calc, what kind of graph do you think this is? Arrow sideways? Oh, F5, sinusoidal. Can you all find that? Yep. So I went graph. Are you the newer one? Yep. Calc. And this looks like, you can see, Jordan, that it's making our our sine shape. So I'm going to reject these arrows sideways, and I'm going to say to my software, try fitting a sinusoidal graph to it. Sin. But it's sine. Sin is when you swear or are late. Sine is the trig function. Okay? Now, here's the only problem. This is giving us the equation in a bit of a funkier notation. Well, first of all, it's calculating the 2 pi divided by 3, or sorry, the 2 pi divided by 6 that we wrote here, it's actually changing it to a decimal, which is 1.04719. Okay, but it is giving me the template. It's saying, okay, A is 25, D is 25, no phase shift. I don't have anything adding to the T, so I can copy this out. Copy. And then hit enter or execute to store it. And now if I go menu, graph, it should be there. Yes? Don't forget to select it. Now, before I hit graph, okay? Gotta know how to get there. So Rach, I'll wait, but we have to be able to do this on the test ourselves. Let me pause. Key things to remember here. When we're talking about the y-axis, what are we talking about? What does H stand for? Height. So if they give me a number in meters, that's a y value. What does T stand for? Time in? So if they give me something with seconds, that's an x value. Okay. First of all, my view window, I'm going to try and roughly match this. I'm going to go, okay, shift view window, x min, minimum time, 0. What's the maximum time? Now on my graph, I only go 6 seconds, but in the question that we're about to do, how many seconds do they give me if you look at the bottom of the page? Sorry? You're right, what was it? 6.5 seconds, isn't it, in the bottom of the page there? So, oh, you know what? 7, sure, that works. Okay? I want to go a bit past 6.5. Scale? Darian, what? Why don't I go with their hash marks, 1.5? It's not a convenient scale, but that way stuff will line up nice. Okay. Y min, what's the lowest this graph gets? 0. What's the highest this graph gets? 50. What's a nice number a little bigger than 50 so I can center this? 60. Good scale. You know what? I'm going to go up by 25s because isn't that what I kind of have there? Okay. And now, with that window there, does that make sense? And there's other windows that would work, but this hopefully will give me, if I hit draw, oh, nail goes up, nail goes down, nail goes up, nail goes, and I could extend this as far to the right, Alyssa, as I want. Alyssa, what are they wanting me to find in this very, very bottom question? What does it say? Stop. Shh, quiet, please. What was that? How far? That's a y value. They want me to do a y calculation. Keep reading. You know what? They're giving me an x value. They want me to do a y calc. Okay, so I'm going to go gsolve. Arrow sideways. Y calculation when x is 6.5. How high is the nail after 6.5 seconds? 37.5 units. It's not meters, I don't think, is it? What's the height being measured in this question? Oh, centimeters. Okay. By the way, 37.5 meters, that's a big tire. Okay, I don't think so. So 37.5 centimeters. H equals 37.5. Everybody get that okay? Pam, you got that okay or no?
No,
Okay, let me pause 1 second. Turn the page or next page over. Okay? So, shh, quiet please. One method to get the equation, Darian, we got this equation in black by using our knowledge of amplitude, period, and phase shift. However, you'll notice another method, we got the same equation by using regression, by typing in those points. And so Gill's method, Gill decided he could use the points N, A, B, those, and perform a regression on them. So what were the points that we typed in? We typed A was 1.5 comma 50. B was 3 comma 25. C was 0, 4.5. Is that right, Mr. Dueck? I'm going from memory. And D was 6, 25. And that gave us almost the same equation. That gave us, yeah.
You have your time and height mixed up in C.
I have my time and height mixed up in C? I do. 4.5, 0. Candy for you, Jordan. Thank you. And you explained that very, very well. Now, if you look at the equation that they gave me, it still gave me the 25, which we found ourselves. The only difference is it's going to give you B as a decimal. It gave B as 1.0471, blah, blah, blah. 1.0471 T plus 25. Now, there was no phase shift. Some of the graphs that you're going to be doing today will also have a number there, a plus C. So you'll add that, you'll copy that out in your equation if you need to. Okay? We didn't get a phase shift this time. And then C says how far after 6.5 seconds. Same way as we found it, we used a YCal value. Okay? In this example, the equations were identical because all the data points were on the graph. It gave us a perfect fit. In real life, little note, we're going to get a best fit. We're going to have some little bit of noise, a little bit of, you know what? Example 1. Here, did they give me the equation or are they asking me to find the equation? Okay, so we're going to type this in. Can you go into your y equals menu, delete the graph you have here? Okay. 12 plus 5 sine bracket 0.524. What am I going to use instead of a T? X plus 1.571, close bracket. And then execute to store it. Here, Laura, they gave me the equation. Okay? Now, they've been a bit sneaky here. They've, Alyssa, mucked around with the order a little bit. So I'm going to have to be really, really careful. Right? We're getting the equation right from there, Taylor?
Yeah, I just can't see the end of it.
It's in front of you. Right?
Got it.
Okay? You don't really need to be reading on the small screen here. I'm glad you do. Good comeback. All right, folks. What's the amplitude? And I'll give you a hint. It's not 12. They're being sneaky. What's the amplitude? 5. The number in front of the sign. What's the midline? The midline is the number that's being added onto the graph. 12. How do I know it's not that? Because that's in brackets next to the X. In fact, it's brackets and backward. That's not the midline. The midline is 12. And they were sneaky because I've always put the midline afterwards. Here they put it here first. So it says this: state the amplitude and the equation of the midline, and hence determine the maximum and minimum depths of the water. Get your non-writing hands out. Okay? What's the midline? How high? So hold your hand there. That's 12. What's the amplitude? So what's the maximum height if I go 5 up? Okay. What's the minimum height? 7. What are we graphing, by the way? If you look at the question, this is the depth of water in a harbor. You know what? This is low tide, 7, high tide, 17. And if you don't think that Vancouver ports know all their tides to make sure ships can get in and out, absolutely. You may have noticed if you ever go to Stanley Park on a Sunday, that's when the cruise ships drop their passengers off by Canada Place, reload, and then take off. But they're so big, they have to take off at low tide to get underneath the bridges. And so you'll see when it's low tide, these cruise ships going underneath the bridges without much room to spare. They certainly can't do it at high tide. Okay? Tide goes up, tide goes down. Tide goes up, tide goes down. Hey, that's a trig function. It's a trig function. What's the period? Well, the period, Julia, is going to be 2 pi over the number in front of the x. Although this time it's a t. What number is in front of the x?
0.524.
Yeah. What's the period? Let me find out. 2 times pi divided by 0.524. 11.99. You know what? What's this really supposed to be? Every how many hours? 12 hours, right? Every 12 hours. Okay. What's the highest this graph gets? What's the lowest this graph gets? So if I was doing a suitable window, I think I would still start 0 high. But what's the highest it gets? What's a nice number above 17? I would go from 0 to 20, maybe go up by 5s. What about my x value? Well, I would start from 0. How long is one full period? How many hours? 12? You know what? We could go from 0 to 12, but what would make more sense if we wanted to do a whole day? 24-hour day. Each hash mark be every, what, 2 hours maybe? Let's enter that view window right now. So I'm going to go, I've got the equation in, right? You guys have as well. Shift, view window, xmin, start at time 0. Let's do a 24-hour day, scale 2. Ymin 0. By the way, you could do a Ymin of 6 because the lowest it gets is 7. I always like to see the ground. That's just my personal preference as a physics nerd. Ymax 20, scale 5. And if we're lucky, tide goes down, tide goes up, tide goes down, tide goes up. Does that look okay? All right. Giancarlo, what's part D you want me to find? So here's my question. Here's my first question. Is part D asking me to find a y value or an x value? Okay, you've guessed. How can I know? Go look at the original equation they gave me. What letter is sitting where the y is? The original equation at the top of the page that they gave me. What letter is sitting where the y is? No. What? See the equation? What letter is sitting where the y normally does? What letter is sitting where the y normally does, kiddo? No, in front of it. D. What does D stand for? In? Meters. Okay. So if they're asking for meters, they want me to find a y value, right? Are they asking me to find meters? Yes. This is going to be a y calculation. You guys can make a little note if you want here. This is going to be a y calculation. Now I got a bit of a problem here though. What time do they want me to do a y calculation? 2 p.m. If I go gsolve ycal2, is that 2 p.m.? I heard someone mutter it. What do I have to enter as my x value? 14. That many hours past midnight. Okay? So, gsolve ycal 14. How deep is this harbor at 2 p.m.? 14.5 meters. That means if you need more than that, a ship can't leave or come in. E says, a ship requires a minimum of 8.5 meters of water. It's in harbor at midnight. By what time must it leave to prevent grounding? Oh. Do they want me to find an X value or a Y value when they say by what time? Let's see. D, my Y value is measured in meters. T, my X value is measured in hours. What do they want me to find here? A time or a depth in part E? A time. Do they want me to find an X value or a Y value? Which one? An X value. They want me to do an XCal. So, when Y is what? When Y is what?
8.5.
Yep. Now, bit of a problem here. This is saying this ship needs to leave by 4.47 hours. Not saying 4 hours, 47 minutes. It's 4.47 hours, and they want this to the nearest 10 minutes. How do I change that to hours? Sorry, to minutes. How would I change 0.5 hours? Half an hour, how many minutes?
30 minutes.
How could I change a 0.5 into a 30? 1 hour, how many minutes? How could I change a 1 into a 60? How many minutes? Quarter of an hour, how many minutes? How can I change a 0.25 into a 15? Still no one? Okay. 2 hours, how many minutes? 2 hours, how many minutes?
20.
So how can I change that into a 30, that into a 60, that into 120? Times by 60. So I'm going to go 0.47 times by 60. You know what? This is 4 hours, 28 minutes. Really 4 hours and 30 minutes if I want. But I'm going to say equals 4 hours, 28 minutes. It's got to be out well before 4:30 a.m. Otherwise, this ship is going to ground on the bottom, and that's expensive. Then you get an oil spill or a leak or yuck. Don't want to do that. Suppose they go out. What's the next time they can come back? Do you still have, where am I, Mr. Dueck? Graph, draw, G-solve. This was a X calculation when Y was 8.5, and that gave me that value. I think the next time they can come back is right here. How can I find that? How can I find that? How can I find that? Should I go an arrow sideways? Then that jump to the next one? Yes? No? Yes?
Yeah.
So, 7.5 hours. You know what? Half an hour is 30 minutes. This person can't come back until around 7:30 a.m. And then they are good until 1600 hours, 4 p.m., just before 4:30 p.m. Got to be up by about 4:25 p.m. Okay. So you're going to have, Rachel, two kinds of questions. They're either going to give you, if you look in the homework, a table of data to get the equation. First Ferris wheel ever built. By the way, the first Ferris wheel ever built was huge, still one of the biggest ever. Or they're going to give you oh, nope, they gave you the graph there so you can get the points. Or they're going to give you, like in number 5, the actual equation. And then you can go straight to your graph instead of having to do the regression to find the equation. Is that okay? Did I pause or am I live? What's your homework? So, number 1. Okay. Number 2. Number 3. You'll learn a new word for daddy longlegs, which aren't spiders, by the way. They're opalioneses, however you pronounce that. 4 is good. Yep. You can cross off 4F and 4G. Or sorry, 5F and 5G. Oh, sorry. 5 is good. I missed 5. 5 is good. You can cross off 5F and 5G. I'm sorry. You can keep 4F. Absolutely keep 4F. Absolutely keep. In fact, you know what? I like 4F. It's an amusement park ride. It's a Ferris wheel. My physics kids should know there's no way I'd ever cross off one of those.
Is 4F going to be on the test?
Good chance. Okay. Number 6. Even a siren, the volume gets louder, gets quieter, gets louder, gets quieter. So number 6 also, I think, will work, except you can cross off 6F. Cross off 6F. 7 is good. 8 is good.